Okay, good morning and welcome to this social university. So we will talk about Java Social JSR and Agorava project and project around social media in Java. Let me present myself. So I'm Antoine Sabot-Durand, a French Java expert. I'm working at Ypon Technologies, a French IT company. I'm an architect and a tech consultant. I've been working for 16 years in IT. Right now in the Java and open source Java sphere, I'm working on Agorava. It's my main project. I'm also a member of Delta Spike project, and I'm a member of the expert group on CDI 1.1. You can follow me on Twitter on this address.
Yeah, I'm Werner Keil. I have quite a lot of hats, almost too many to mention here. That's why the cosmopolitan comes in rather well, because I'm also traveling a lot. I've been in IT for a little over 20 years, and I've been mostly in open source Java. I'm one of the two only individual members of the JCP Executive Committee. I lead an Eclipse project called OAuth that is a little more in the area of embedded and standards for M2M and the Internet of Things, and I'm also very active in the DevOps and Agile community. So we don't have quite as many episodes as Star Wars has or may have in the near future under the new owner, but we have at least around 4. So the first one will be about the rise and fall of the JSR social approach. Also some of the projects that led to it or that inspired us. The second part will be about standards in social media in general, the standards, non-standards, and what actually should be a standard for social media. Then we are going to look at the Agorava project, also how it got there. Related JSRs like JSON, security, identity, and differences from some other existing social APIs that are out there or that have just recently been introduced. And the last part is a technical, in-depth look on some of the components under the hood of Agorava, like Jackson, CDI, JAX-RS. Then we'll have a Q&A and probably some more live code demos if you're interested. So how many of you have heard of JSR 357 or followed? Okay. So, of course, JSR 357 was not the first ever approach to social. Twitter for J. Have any of you played with Twitter for J or know it? Okay. So it's kind of an unofficial Java library for the Twitter API. Its author, he's also a member of the Java community process. He briefly represented Twitter there. He's no longer with Twitter, but he was for a couple of months. And he also was intended to represent Twitter at the Social JSR expert group until Twitter kind of stalled that effort. We'll come to that very soon, some of the reasons why they may have done so. Maybe you have also heard some of them in the social media and on the internet in the last couple of weeks and months. It's light. It's also based on Java 1.4, so it can even be downscaled to what is currently J2ME. There's also an Android version of it, so it's definitely very lightweight and versatile. There have been talks with Yusuke, and now that he's no longer working at Twitter, he may actually have more time for that. that he's considering to look at the Twitter client for Agorava, and he may also contribute to that or offer some form of bridge between Twitter for Chez and Agorava. Scribe is a Java framework for OAuth functionality. It also allows you to configure and has connections to some of the popular social media applications that use OAuth in either version. And it's also relatively lightweight. There's the only external dependencies that's not its own code base is Apache Common Codec. And as of version 0.5, it's the heart of Agorava's OAuth functionality. DALI core. Well, since you're, at least some of you must be from Belgium, how many of you have heard of DALI core? Oh. Okay, you will. Ah, one. So it's actually, it started as a content management system. It was started by a Belgian company that's also actively involved in the Belgian Java user group. And it is also, you will see that when I'm looking at the differences between different systems, it's relatively scalable and makes use of almost all the aspects of the Java EE6 platform. And it was used, I can't remember, there was a presentation at Java 1, but for some, at least, state election here in Belgium, parts of DALI core were actually used inside the Glassfish container, and it had very significant traffic, something like 10,000 of concurrent users. So it probably wasn't as widely used as the recent American presidential election, but it definitely saw a lot more traffic than, for example, the election for the JCP Executive Committee, which usually has, unfortunately, a slightly lower turnaround. So it adds functionality for permissions on top of what Java EE already provides. The focus are actually users and permissions, and it also has connectors to some of the most popular social media services like Facebook, Twitter, or Google Connect. And the DALI social modules extend DALI core. Spring Social has also been around for a little while. It inspired Agorava. It has been around, although I was just down at the Spring Source booth, and there's neither a button nor any person who actually has laid their hands on it, so it seems a little bit of a niche inside Spring as well. I know at least one company in Hamburg that also uses some of the libraries of Spring Social in their own social CMS product, but that's currently the only real product based on Spring Social that I've come across. And of course, it's tied more closely to Spring. We're also going to look at that a little more when I compare the different social clients. Yeah, about earlier this year, actually literally last year here, Antoine and I met at the Java EE BOF, and we're looking at how Theme Social could be contributed into the JSR inside the Java community process. There were a few talks with Pete Muir and Yusuke Yamamoto and others at Java 1 last year. But here was kind of the first face-to-face, if you want. And then a few months later, in early 2012, we proposed it as joint spec leads. It was submitted, and it was not unanimous, but in the end, there was at least a 3-vote difference that resulted in the JSR to be stopped under this number and at this time. well, then let's look at what actually went wrong. So this picture is there's a little symbolism to it. So you see the big blue van that has smashed the Tesla Roadster, which of course many people also think is kind of ahead of its time with regards to a sports car being run by electricity. Well, I'll leave it up to your imagination what the big blue car might be. But let's say that there's a company that's also associated with big and blue. One of the criticisms was it was too broad. It certainly may be the case, especially because we also tried to tie in some of the aspects that DALI Core provides, or that you may see in some of the various open social approaches that allow you both to host your own social network, but also consume it. And that was something that some people found a little confusing or didn't quite understand how this would tie into Glassfish, for example, as opposed to having a connector and a client that may even work on a mobile device, as you see with Twitter4j. Twitter4j was, of course, also one of the inspirations and possible candidates for this standard. Too soon? Definitely. Similar to the Tesla Roadster, it was at least a few months, if not years, before its time. And you will also see that Oracle, without even knowing of this JSR approach, just recently jumped the bandwagon once again. Of course, there have been approaches by Sun earlier, but these died at the very least when Oracle took over Sun. And there has been recently other approaches. So it's not the last one, but it may have been a little premature in timing, especially with regards to the merge of the JCP Executive Committee, which has happened literally a few weeks ago. So I would actually have also preferred to have both sides of the EC vote for it. And the idea originally was introduced to the JCP by Oracle themselves on the mobile side, when they tried to sketch out the future of Java ME. You will see it downstairs and probably in some of the sessions to come in the next couple of days that at the moment the future Oracle sees for ME is not so much your mobile phone, because there's already Android and iPhone and a couple of others, but they rather think of it in embedded sectors where social may play some role. For example, you have the parking meter that may send you a tweet when your parking money expires, or whatever. Maybe your coffee machine tells you that the coffee is ready when you come home. But at the moment, Oracle mostly considers embedded devices to be kind of the immediate future of Java ME. Therefore, Oracle's own ambitions with regards to mobile social were also a little scaled down in recent months. But they were the ones to first mention those kinds of things. It can't be standardized. Well, there are, of course, things, and you will see in the connection with the identity JSR, that is a future component that we also have a closer look at and plan to use in appropriate areas where there's a lot of discussion. There was also hesitation by many about the identity JSR thing, like, oh, how can we actually standardize an identity, which ranges all the way from your social security card to your Twitter and Facebook and God knows what social media accounts. Of course, all of them have different properties, but neither this JSR approach nor Open Social or any other API tries to standardize every single attribute that every API may introduce or change in the future. So it's more about a reliable way of connecting to all these APIs and bringing them in a type-safe manner into the Java ecosystem. And that is, of course, something that can be standardized. Otherwise, we wouldn't have things like portlets, which, by the way, also was a JSR that was turned down twice before it was finally standardized, and several others that you probably haven't even heard of, but that are also used up until now into Java EE containers. So let's look at some of the standards that are out there in social media. REST is, of course, one of the most important. Most of them use JSON these days. Some still use XML. It's a little bit of a trend from XML towards JSON for identification and authentication, although OpenID was initially introduced and preferred by various portals and social services. It has shifted quite drastically towards OAuth these days. Yeah, a little bit about REST. So let's try again. How many of you have used REST or dealt with it? Okay, that's a lot more. So on the low level, it's based on HTTP, and it's a simple way, more simple. So REST is also something that has more or less replaced, or at least drastically shifted away from the original SOAP, WSDL style web services. You may find SOAP a lot in intranets or some big companies that have just started their SOA strategies, and that, of course, will not shift to REST immediately. But even there, when some new projects come up, they usually start using REST rather than SOAP if they can, and if there's not some corporate policy or infrastructure that makes that impossible for whatever reason. So Java has a standard to deal with that. Version 1 doesn't have a client API yet, but you should also hear in the course of this week, there's at least one JAX RS 2.0 presentation, and I believe there's also a buff. So you have a lot of chances later in the week to hear more about REST here at Devox. JSON, there are several JSON APIs, probably most notably the one by Douglas Crockford. It's mostly coming from the JavaScript and Ajax world, a format that is more lightweight than XML, can be easier transferred, and is more versatile. And it became a standard for online services and all kinds of APIs everywhere, from allowing you to see how many public toilets the city of Vienna has to common social networks. OAuth?
Anders come OAuth. So OAuth is today one of the most used protocols for authentication on the web. In fact, the idea is to delegate the right for an application to act on the behalf of someone. So when you use OAuth, you grant right to an application without giving your login and password to this application to use a service. It was developed at the start by Twitter and the CMS company Magnolia. After a short while, Google joined them, and they work on the standard. It was made a standard by IETF in 2010, and it gave an RFC. There was a lot of work around version 2 of OAuth. It is intended to be simpler to use, because we will see after that we'll have a focus on the famous OAuth dance, and it's a bit complicated. And so version 2 had a mission to simplify all this. But the work on this version was too long, and a lot of actors start implementing it while it wasn't finished. So today there are a lot of critics around OAuth 2 because there are too many implementation, and it was standardized very in October. And there are two RFC on OAuth 2. And as I said, a lot of actors today already use OAuth 2, and they have been using it for 2 years and a half. So that's Facebook, the first one, I think, Google and Microsoft, for instance. Other social networks like Foursquare and Stack Overflow also use them. Today, all the social media used one version of OAuth or the other. They proposed other solution in the past, or they still proposed other solution, but OAuth today is the best, is the preferred solution for all the authentication and right management on social media and more broadly on social service, online services. So to start, focus on OAuth. When you want to use OAuth, the first step you have to do is to create an application on targeted service and have an entry point for the person of the application that will consume the OAuth service. So as I said, we have 3 steps in OAuth. First, you have to create this famous application on the social media service. After that, there is an initialization phase where you have to give the right to the consuming application on the service. That's also called the OAuth dance. We will see the dance after that. At the end of this dance, your application got an access token. It's mainly a public and private key. And this access token will be used in the last step. So the last step is the step that is repeated when you consume the OAuth services, for instance, on the Twitter or get your Facebook timeline. So each request you send to the social media service has to be signed to be sure you are someone authorized to use the service. And the signature, we will see, will be created with the access token you get at the end of the OAuth process. And the token that was created in the first step when you create the application on the social media service platform, and you use both tokens to create a signing key and sign your request with that. We will now have the focus on each of these steps. So the first step is quite easy. You have to create an application, for instance, on Twitter. You go on the developer website of Twitter and sign on, and you start to create an application. So you have to give a name, description, and so on. And the application is created. So for instance, here you have the Agorava application. You've got 2 important things in the end. You have a key in 2 parts. There is a consumer key. Do you see? You see here. You have the consumer key and the consumer secret. Both of these keys will be used to identify the application and to give right to this application to act on your behalf. There's also other things that can be interesting in the application. You can declare some kind of scope. On Twitter, it's it's very simple. In fact, you authorize the application to send a direct message or not. Yeah, there is no very fine-grained authorization. And you give a default callback URL that will be used at the end of the OAuth initialization, the famous OAuth dance. And yes, this URL is not mandatory. You can provide it in the initialization phase when you start it. So let's talk about dancing. So to start the dance, you have to be free. It's a dance with 3 partners. Kind of strange. So there is the user that want to give right to a consuming service application, consuming service server, for instance, and the social media service, Twitter, Facebook, what do you want? And let's start. So, first step, you user, you ask for a kind of resource on the consuming service, so on the application that will use Twitter on your behalf. And this resource needs to have your identity on Twitter to be used. For instance, you want to send a tweet or get some information about your followers in Twitter. So the consuming service server in the step 2 start by asking a token to the social service. So it's called a request token. You have two tokens in the OAuth. You have the request token at the beginning and the access token at the end. So it asks a request token, and to ask this token, it uses the OAuth application keys that we saw before. You see the keys that were generated when the application was created. So it sends this request to have this token, and it can also send in the request callback URL to send the user back to the consuming service server at the end of the connection. So if the token given are correct, it corresponds to an existing application, the social media service sends back this famous request token. So the consuming service server has to redirect the user on the social media login page. I don't know if some of you already used those kind of service when you use your Twitter login to Twitter account to log on GitHub or any service. That's the part where you have the Twitter login page that appears in a pop-up or in your browser. So you are redirected on the Twitter login page or a social media login page, and you have to enter your login and password, and give right to the asking application to do things on your behalf on Twitter. Read your timeline, look at your followers, and so on. Next step, when you gave the right authentication, and it's okay, you authorized the application to use the social media on your behalf. The social media redirect the user on the original application with the callback URL that was sent at the beginning, or if there wasn't a callback URL given in the first step, it used the default one that was defined when the OAuth application was created. It also sends in the callback URL a parameter, which is a verifier code. It's a code that can be used to check that the request is known on both sides, on the social media and consuming service server. After that, with the code, the verification code that was sent back, and the request token that was obtained in the first step, in the third step, we can ask the social media service the famous access token, the final token. And in the final step, the social media returns the access token that can be used by the consuming service to use Twitter on the behalf of the user. Nice dance.
I think the French actually have a name for a dance with three partners.
I'm not sure. I don't understand what you're saying.
Ménage à trois.
So in version 2, there is a simplification of this dance, because OAuth 2 made mandatory to use SSL as a communication layer, so all the exchanges are encrypted. That wasn't the case in OAuth 1. That's the reason why we have a lot of comeback and forth in the process. So it's quicker in OAuth 2, but we still have some step. So in the first step, the same. We ask for kind of resources on the consuming service server, and we have to ask it with SSL. Consuming server redirect user on the social media login page, so it doesn't ask a request token. There is a redirection with a verifier code. With the code and the request token, the consuming service asks the access token, and the social media returns the access token. After the dance, so you've got your application, and you've got your access token. So you've got two keys. In fact, you have 4 keys. In each keys, you have a secret part and a public part. And now you can start to sign your OAuth request. So let's pretend you have to send this request on Twitter. So this is an update request, and you have a parameter to ask Twitter to include what is called entities on Twitter. It's kind of metadata on the tweet about all the hashtags and including URL and things like that. So we ask to send an update and to have in the answer the tweet that was delivered in the Twitter system. We have all the metadata around. So we try to send a message, a status message. Hello, ladies and gentlemen. Signed OAuth request. So we've already have an encoded message to have an ASCII, an URL compliant parameter, and we have now to work on the signature of this request. In the upper part of the code, you will see it's the HTTP header. In the lower part, it's the body. So first, we take all the parameters of the request and all the parameters that are in the header. So we've got the status. We've got the parameters specific to this request that ask to include entities. We have all our keys. So we have the OAuth consumer key. That's the key that was created in the application you use for OAuth. We have two parameters regarding unicity of the request. There is the OAuth nonce, that's the unique identification that you can generate as you want. Here we use a library to generate it. And you have the OAuth timestamp that correspond to the time when you send the tweet. You have the signature method, so the algorithm used to make the encryption of the signature. So by default on Twitter, it's SHA1. And you have your OAuth token. That's the access token, the public part of the access token you got in at the end of the dance. And the OAuth version, for the moment, Twitter only supports OAuth version 1. So you take your request and you create a kind of parameter string by concatenating all the information. So you have the parameter, include entities. You have your key, you have everything we saw in the previous slide is here. From this first string, we create a base string with the REST verb, with the URL to send the request, and we encode all this to have something with only alphanumeric characters. After that, we use both keys to create our signing key. So we use the application consumer key secret part. So it's the famous key we got at the creation of the application on Twitter, and the access token secret part. So the access token we got at the end of the OAuth dance. We concatenate both of those keys, and we've got a signing keys. We use this key to sign the request. So if you compare with the first slide, we now have another parameters in the header. We have an authorization parameter with all OAuth information in it. And the most important part of this header is the OAuth signature that was created by using the signing key on the base string that was created from the content of the request. So when Twitter will get this information, it can try to recreate the signature with all the information we've got there and compare to see if you are the right person, if the service is the right person, if there's no hacking, and be sure that it's an authorized request. So we saw Werner start to talk about standard part in social media. There are also non-standard part, and that's perhaps the reason why the person in the GCP, the person that voted the JSR 357 down, said that it was not standardizable. Because these non-standard parts are all the rest. Today we don't have a standard identity management. And we don't have, in fact, we don't have any standard API across social media. So we have those low-level standard JSON, REST, OAuth. But after that, all the data that is exchanged is specific to the social media. So you don't have a unique way to define a user. You don't have a unique way to define an update and so on. For instance, if you take something as simple as a user profile on Twitter, you won't have information like the email of the user. You will have its Twitter account name. You will have a URL for the user picture, and that's all, I think. On Facebook, you will have a lot of information on the user. You have the full name of the user, the email of the user if you have the right to see it, and you won't directly have the URL of the picture. You have to make another request, to have the URL of the picture of the user. So you have two different ways to define a user on two major services. So today, we don't have standard for that. And I'm not sure, but I think it won't come very soon.
Identity is on its way.
On its way, but I'm not sure that social media will use it right away.
That's another question. Of course, some of them are not based on Java, so it's not for all of them.
And that's going more than that. So you don't have standard in API, but you don't have no guarantee about the stability of the API. So you don't have, when you start developing an application for Twitter, Facebook, LinkedIn, you can discover in a few months that the API will be deprecated, and you have to start again from scratch, or nearly from scratch, to develop your application, because in 6 months, all the things that you are doing won't work anymore. That's the case, for instance, with Twitter. The version 1.1 of their API were launched 6 months ago, perhaps 4 months ago, and the previous version will be deprecated in March. So in March, you won't be able to use your old application that was developed on the version 1. And when there are such change, there is no backward compatibility that is guaranteed on this change. So we have the non-standard part here. So with all this information, how can we define what would be standard in social media, for social media? We work a lot on this subject. The idea is to have a kind of a core or earth that provide basic service. So all the standard that we saw, OAuth and the REST request, we have to provide an easy way to manage multiple connections to multiple social media. And as the service, the online service, the social media don't provide standard, we have to create them for us. So we have to find a way to provide some kind of polymorphic services to enforce those standards. So to define a kind of standard user, a kind of standard update, and standard timeline, and so on and so on. So this core engine would be a kind of a connector for social media. And after that, we will have to create some specific module for each social media. So that's the idea that was started at the end of the JSR 357. That was an idea that we had before, but we saw that we need to work on it and make some proof of concept around this idea. So as we talk a lot, I think it's time to show a bit of demonstration. So in the second part of the presentation, we will talk, we'll have a focus on the Agorava framework. That is an attempt to build this standard, and that will perhaps go to the GCP one day. And before talking about this standard, I think it's a good way to show you a demonstration of this framework. So we have a little demonstration application. Oops. Try to reload it online. Ah, that's clean. Okay. Okay. I'm going to close my... That's the visiting effect. Don't you know? Because I played before the talk and break something, I'm afraid. Start with another. Okay. Does it work here? No, great. That's horrible. What happened? Okay, so we will we will do this demonstration after the pause. We will have the pause in 30 minutes, and we'll try to fix it to show you this demo. To show you this demo. I don't understand. That's the DevOps effect. So let's start talking about Agorava project, and we have the demo after that. So after this famous Java Social JSR was rejected, we start about thinking, building a real project to go back to the GCP with something that works, and make the demonstration that we can have some standard around Java Social. Before Agorava, there were all this project we show you in the first place, and another project that wasn't only mentioned in this part. It was SimSocial. SimSocial was part of the SimFree JBoss project. So SimFree was a bunch of CDI extension providing services like sending email, building reports, enforcing security, and so on. And there was a social module in the SimFree project. I was in charge of this social module. And this work on SimSocial was used to start the Agorava project. At the beginning of the year, the Sim project was stopped because all the CDI initiative was merged in another project, in a broader project, which is called Delta Spike. And all the people that were working on Sim switched on Delta Spike. So Agorava was born after the GSR 357 attempt and the end of SimSocial. One of the goals of Agorava, the first goal is to create a framework around social media, and one of our goals is to become the missing proof of concept to go back to GCP and have a new social JSR. Before talking about Agorava, I will let Werner talking about linked concept.
Yes, as I already mentioned, there's an approach in the Java community process that was started a little bit before the Social JSR idea, and that's a JSR that's in progress right now about identity. So let's talk about the concepts of identity, privacy, and trust first on a rather high level. So identity attributes are properties of a digital subject. So any of you, but it can even be not just a person, but also something else that's valuable. So I was speaking at a conference in Nice a few weeks before Java 1, and there they had identity protection with RFID tags for cars or even for Gucci bags. So some farms also inject RFID tags into their most precious bulls so they don't get lost or stolen. So it can be the identity of almost anything. There was some interesting talk some years ago when Borland was still alive by somebody at Borland who also said, like, yeah, they wanted to use the social security number as an identity, but then it turned out the US armed forces do not only employ people, but they also have labor animals, dolphins to find mines underwater, or mules to transport their equipment into the most remote villages of Afghanistan. And of course, they don't have a social security number, so in the end, they had to find something else, like a generated ID instead of the social security number. So that is a good example that identity does not only refer to people, but can refer to almost everything. And in the Internet of Things, that can even refer to your phone or to some sensor that's installed somewhere. A digital subject is a digital representation of that in the Internet or anywhere in the digital world. Privacy, of course, you have probably heard about many cases. One of the most popular social accumulators, Hootsuite, has just had to confirm that they accidentally shared the identity of other users in some form. So there was a privacy breach in what is considered to be one of the most important social accumulators and analyzing site out there in the entire industry. So of course that's quite significant. Trust is an evaluation of the reliability of a representation of a digital subject. And the identity as such is a set of identity attributes that make the subject unique and identifiable. So a little bit before JSR 357, JSR 351 was initiated and accepted. It's a Java Identity API, not only for social media, but of course that's one of the important use cases out there, considering that Facebook alone now claims to have about 1 billion users, or let's just say digital subjects, because of course some of them may be duplicates or bots, so it doesn't necessarily mean that there are 1 billion people out there who are actually sitting there, but 1 billion accounts that are more or less active. The attribute service is composed of attribute providers, and the specifications for this will provide repository integration also by third parties. So you can also have companies like Facebook then integrate with that. The reference implementation, it's a project called Nobis that provides specific integration, for example, with Facebook, Twitter, LinkedIn, and also other use cases, for example, the social security, healthcare, and the digital patient record is also among the most relevant use cases that Nobis is currently looking at. And it will connect to, for example, Facebook, Google ID, and a more generic OAuth connection for any social or similar public API that uses OAuth tool. So here's a brief example how this may look for Facebook. This is actually from the actual Nobis code base on java.net. The parts in blue are the standard parts. So those are the parts that are actually defined by the spec. So here you can see a Facebook repository agent that implements the generic repository agent, an attribute repository, and as I said, it's just a small subset. It's not the entire class, but the relevant parts that return the attribute repository. Another example is the repository itself. So the agent that returned the repository with the getter on the previous slide. So here's relevant parts. And again, the blue parts are those that the JSR 351 spec defines and standardizes. So, for example, attribute repository, repository descriptor, and ID predicate. The ID predicate is also interesting. That's why I took this out of several other methods, because it is almost like a query language. So you can see there are and, or, greater than is included in. So this allows the big challenge that we have with almost every social network, that attributes and information in there may change. So with a mechanism like the query capabilities via the ID predicate, you can then try to filter out or do an almost SQL-like query. And for example, Facebook actually is one of the few social networks that also has a query language out there. So in the case of Facebook, you may even use JPA as such in the Java EE language. And that was one of the things that we also, kind of an idea that we proposed in the JSR 357 initiative, which probably, again, may have been too broad, and since it's only exposed by Facebook, that is probably not going to work for many other social networks or sources of identity. So that is why the 351 expert group, which I'm also a member of, looked at how can we create this query, and it's almost if you look at it on the big picture, it's almost a bit like in JPA, where you're trying to look at, okay, does this API, for example, contain a certain piece of information that I'm interested in? Let's say social security number or date of birth or I don't know what, URL of the user's avatar. And last example code here actually shows a mapper from the JSON object, which is not standardized by JSR 351, but you will find this in similar ways in json.org, and there's another JSR currently in place for JSON. So the JSON object is then, in this particular code example, it's still the API by Douglas Crockford, but since there's another JSR by Oracle, the code will soon be migrated towards the JSON JSR, at least at the time when the JSON JSR releases its first binary code drop. It has already passed EDR around the time of Java 1. So if you are curious about the JSON JSR, you can also look it up on java.net and play with it if you're using JSON, not just in social media, but other areas. And this shows how the JSON object that you get will then be mapped into a set of ID attribute values. So, as I mentioned earlier, there's not just Agorava, there are at least 2 or 3 other serious approaches. One of them is Spring Social. As I mentioned, there should be at least one company out there that uses it in a commercial product. At least the people who represent Spring here down in the booth do not have a great exposure to Spring Social. I asked and there was nobody there who actually actively contributes to the project, so they probably won't have taken the time to come up here. It works only primarily with the Spring framework, so it's a lot harder, if not impossible, to decouple it and use it, I don't know, with CDI or with something else. Also, other UI frameworks than Spring MVC may be harder to integrate. Agorava Socializer, for example, has already been migrated to Wicked by some independent party. So there exists at least another UI framework implementation for Agorava Socializer that may not be as easy in the case of Spring Social. And the focus primarily seemed to have been on Facebook. So there are a couple of examples on GitHub, but most of them are for Facebook only. And it also demonstrates that Spring Social has mostly a single service approach. So the accumulation and the polymorphic approach that Antoine already mentioned, that is one of the key drivers behind Agorava, is not so much present in Spring Social.
Excuse me, polymorphic approach that we will see in the demo when it will work.
After the break. So, yeah, as I mentioned, as I already saw here at Devox, the Spring community does not seem to invest a lot of effort. There may be 1 or 2 people, I'm not even sure if they are full-time dedicated only to Spring Social. At least the commits on GitHub are kind of indifferent. So there's activity here and there, but it's not massive. On the upside, if you're using .NET beside Java, of course, maybe Devox is not the perfect place to talk about .NET, but if you're using .NET or if you're using both Java and .NET, then Spring Social may be somewhat easier to support both platforms because Spring Social also has a .NET implementation. I've not personally looked at it and I have not heard about anybody using it in a commercial product, but at least it's out there on GitHub and you can have a look at it if you're a .NET user or if you have clients who also need .NET support.
Who already used the Spring Social here? No one.
No
okay. One person. Okay.
Yeah, Dalicor, I already mentioned. This is an initiative from Belgium, and it's also rather tightly integrated and supported by Glassfish. So it's not directly a Glassfish project, but Glassfish is its preferred container. It also offers a container and a CMS, so if anybody wants to host their own social network, like the Lady Gagas out there or other people who want to have their company's social network, then they may also not only consume social content, but also host it.
Provide.
The persistence support is very rich. Both you can use entity beans and EJBs or JPA. What's a little fuzzier is the separation of modules, especially the clear separation in things like in Agorava. You have an Agorava core module and you have certain implementations for CDI, but you're not bound to CDI if you want another implementation, and we actually working on implementations that use alternate dependency injection containers like Juice or something similar on the mobile side. Dalicore is more tightly integrated with its implementation. So it's more for the big Glassfish or any compatible Java EE container. So it seems a little heavier. You can use entity beans. That makes you way scalable, and they have already demonstrated this here in a commercial use case in this country. So it also has a proven track record of professional usefulness, but it may be a little heavier. So if you want to use this on your Android device or even on an embedded platform, Dalicore may be a little hard to port there. And even inside the Java EE, it looks like you may need a container that supports the full Java EE spec and not any limited profiles like the web profile. But of course, Glassfish support and the demonstrated scalability are definitely things that make Dalicore worth looking at, especially if you're based in Belgium, because there's also professional support here of people who have contributed to it or started writing it. Then at Java 1, a little bit as a surprise move, there was a company that Oracle has gobbled up, some smaller social API or social analytics provider. I think I heard in the Silicon Valley the company was called something like Just Now or Just Right or whatever. And for a Java 1 social track that I attended while at Java 1, Oracle has literally at this particular track contributed the code to java.net. They called the project Oracle Social Link. The idea may have been to kind of have a slight association with the Oracle Eclipse Link project, which is the reference implementation for JPA. In fact, the author didn't really have that in mind, but one of the key interfaces he simply called iSocial Network. So that is also something that if you're using Eclipse or if you know Eclipse code and if you're consuming plugins, you will probably come across those uppercase I's a lot. Other than that, it's mostly used by either IBM or Microsoft on the .NET side with Microsoft Foundation classes and what has now become out of that in the new .NET universe. So in most common Java APIs, at least you will rarely find this I notion. Other than that, it also still looked a little half-baked and immature, unfortunately. Although it's supported and sponsored by Oracle, it was only written by a single person, not an Oracle employee, but somebody they hired to do that on a contract basis. And you may look it up. We have a link at the end of the slides. But when I last checked it, when we were talking in Morocco, I think there were like 4 people who actually joined it, and three of them are Oracle employees. So the community support, as for example, Sun had something called Social Site, I believe, on java.net, which was based primarily on the ideas of open social. So it was kind of a spin-off of the Apache Shindig project, which was an earlier implementation against OpenSocial. I think they are now stuck at OpenSocial 0.8 and waiting for OpenSocial to reach version 3. And then at some point in the future, maybe Apache Shindig will also progress towards OpenSocial 3. And at some point, Sun also picked that up. They created a bit of a fork of Shindig, added some of its own, I think it was already Glassfish at the time, and that was called Social Site. You can also find it on java.net. It's no longer actively developed. It's dead. All the developers have left Sun or Oracle or the project. Nevertheless, there are still about, I think, 120 to 150 people who are observing the project, so who are official members on java.net. So looking at that former Sun project that has almost 150 followers as opposed to the new big initiative by Oracle that has only 4 to 5 followers, of course, it looks like there's a lot of catching up to do for Social Link. The modularity is also worse than all the others, so even DALI Core has a better separation between API and implementation, and Social Link makes practically no use of Java EE. So it's just a general Java collection API and other stuff that you know from Java SE. So since it has almost no dependencies on other external components, like I think the only similarity that you will find with Agorava as of now is that they're both using Scribe for the OAuth functionality, but that's practically it. So Oracle Social Link, except Scribe, has almost no other external libraries that it's using. So should there be any further drive that Oracle invests behind that, then it may be a bit of a light version that you could even find useful in a mobile or embedded environment. Another problem, of course, compared to especially Spring Social and Agorava is that there's no clear and clean exception hierarchy. So everything extends exception here and there. There's no central exception. So if you need to do logging and exception handling inside your application, Oracle Social Link will usually leave you with the bare bones that Java as such provides. And you will rarely find anything where you could, for example, catch a central social link exception. That just doesn't exist. There are several exceptions, but unfortunately, there's no clear hierarchy. So it has potential, and maybe if Oracle doesn't run out of interest for this subject, there's sure the interesting opportunity that together with other proof of concepts, including Agorava, there may be something to contribute to a future JSR initiative. But as of now, unfortunately, Social Link from an architectural point of view seems to be one of the weakest.
Okay. Now that we talk about other project, let's focus on Agorava. So we will start to talk about the project, the goal, its roadmap, and the technical part. So there will be more technical slide coming. So the goals of the project is to provide some kind of generic service across different social media. In fact, it's to bring the standard that lack today across social media. The idea also is to have a kind of dynamic discovery of media module. I made a POC with people in Surly in April, and we built some kind of POC on OSGI with Agorava, and we could add dynamically new social module at runtime. We will have to work again on this POC, but it's very interesting. So all the modules are dynamically detected at the beginning of the application, at the starting of the application, and also provide a way to manage multiple social media connection. So multiple social media connection and multiple connection on the same social media. And finally, also provide high-level services and binding to interact with the social media. So to have all the REST API available with Java. So let's talk about the big picture, the architecture of Agorava, and we will have a pause after that. So there are two main parts. The most important part is the Agorava core, and that's the part that could be become a standard. So you have a layer in this core, and layer in the lower layer is the API that is shared among all the core. On the API, we'll have Java EC implementation. So today we don't have it right now, but we'll have on our roadmap to have a full Java EC implementation. On top of that, we will create an @inject implementation, @inject API and implementation, because @inject is not a specification that is detailed enough to be implemented directly. And on top of that, we plan to provide free implementation, the CDI implementation that exists today. So in this schema, all the block with a plain drawing exist. The Java EC implementation is a work in progress, and the one with the dash are in the roadmap. So today we have the CDI implementation, and we plan to bring one or two other implementation on a framework that supports the JSR 330, so the famous @inject JSR. So that could be Goose or Spring or both. There are some people that asked for Spring implementation, so we are working on that, and perhaps we will do it. But we still compare with a Spring Social, as there is a social solution in Spring. Perhaps it will be the first one. But Goose is definitely on the roadmap. Because there is nothing on this framework, and it could bring us on the mobile part with Goose for Android, for instance. And on top of, outside of this core, of this Agorava core, we define modules. So today we have 3 official modules. One for Twitter, one for LinkedIn, and one for Facebook. There are other modules that are in progress. One for Stack Overflow, one for GitHub. There is also work in progress, but it's a bit stuck right now for Square. But there are a lot of people working on modules on Agorava. If you go on GitHub, you will see all of them.
Chuck, Jenna, I believe also are working on at least one for TripIt, the traveling site, and a couple of others. So they were originally intending to join the expert group, and they also continued to support Agorava, and they are working on some independent modules on GitHub, which may, if they're mature and useful enough, also become part of the official distribution.
Yes. So today we are in a 0.5 version. We are planning the version 1 at the beginning of 2013. And in this version, there should be other implementation than CDI. But today, with the CDI implementation, you are not stuck in Java EE. We made some development outside a container on command line Java program or application that runs on JT or Tomcat. So we can, as CDI can be used outside of the Java EE container, we pay attention to keep that functionality while we don't have a solution to be outside Java EE to work on light container or in the command line development or I don't know, Swing client or things like that. It could be possible today with CDI. So you have to use the CDI AC extension that is provided in, for instance, Weld or Open Web Beans, but it works. It is tested for Agorava. So what is I said on the slide, the big item on the roadmap are full Java IC support. Today we have partial one, and JSR 3.3.0 support for version 1. So before talking about detail architecture and class and thing, I proposed we make a kind of pause, let's say for 15 minutes, and we will back on 11:05. It's okay? And we will have a demo, we will have a code, and we will show you some tools we are using to develop our modules and to develop our binding code.